Okay. Pranam everyone. So I think we should start. No other person will join. Already low attendance. So sit comfortably. Upright your spine. Close your eyes. Adapt Gyan Mudra or Chin Mudra. Now deeply inhale. Inhale deep and long. Exhale completely. Inhale deep and long. Exhale all your toxins, all your negativeness, all your messiness. Inhale the enthusiasm, inhale the energy, inhale the positiveness, and exhale your complete letharginess. Inhale and feel that you are physically active. Exhale and feel that you're mentally relaxed. Okay. Now, adapt Namaskar Mudra in front of your chest and inhale deep and long and start the prayer. सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामया सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् ॐ शान्ति शान्ति शान्तिः. Now rub your palms, put those palms on your facial muscles, feel the warmth, feel the energy, and open your eyes with a smile. So, till where we have covered yesterday?
कार्डियक साइकिल मैम, आपको कार्डियक साइकिल
Yes. Any doubt regarding cardiac cycle?
नो मैम.
Okay. Usha ma'am, you was telling that you having some doubt and you are going to explain it. Is it okay or you are going to explain it once more? Okay. I think Usha ma'am is being outside. No problem. So we will continue. Let me share my screen. Yes. Okay. So we have done till cardiac cycle. Yes. Now we will move to heart sounds. First one is lub and dub. So lub sound is fairly loud due to closure of and atrioventricular valves. Okay, means when an atrioventricular valves are closing, at that time lub sound is coming, and dub sound is a bit softer than lub sound, and it is due to closure of aortic and pulmonary valves. That is, stethoscope is used to hear the sound, heart sound. Means understand the concept. When the lub and when dub sound is occurring, means when atrioventricular valves, means tricuspid and bicuspid or mitral valves are closing, at that time lub sound is occurring. Means just after contracting the atriums, when blood is flowing, means after blood flowed to ventricles, then atrioventricular valves are closing. Means blood is transferring to ventricular part, then atrioventricular valves are closing to prevent the backflow to atrium. Now, at this time, lub sound is coming. Okay. Now, when dub sound is coming, just after contraction of ventricles, right? When ventricles are being contracted, then uh, flow of blood is going to pulmonary artery and aorta. So, just after blood is being transferred to pulmonary artery and aorta, then aortic and pulmonary valves are getting closed. So, at that time, dub sound is occurring. So, lub and dub are the sounds of heart. There are much more detailing sounds of heart that are murmuring, known as murmuring of heart, and many more details are there in case of medical science. But this is enough for basic physiology, and you
Can
all
you
know.
repeat that? I couldn't hear anything that you said. I I don't know why, but your voice was not audible to me.
Is it for everybody or is
No,
it
ma'am.
just for Osama?
No, ma'am. I can hear you.
I can hear you now, but you started with the slide, but what you said in the beginning, I couldn't hear that.
Please inform me. Is it for everybody or is it just for Usha ma'am? Then I have to repeat if it's for everybody.
No, ma'am. Is it? I think for Usha, ma'am.
Okay. Then Usha ma'am, I'm briefing you
Yes, ma'am.
in short. But if you do having any problem, then go to recordings. Okay.
Yeah.
The thing is that lub sound occurs when closure of atrioventricular valves, means atriums are contracting, blood is flowing to ventricles, then valves of atrioventricular valves are closing. That time lub sound is occurring, and just after contraction of ventricles, blood is flowing to aorta and pulmonary artery, then aortic and pulmonic valve is closing. That time dub is occurring, and these two are the basic or main sounds of heart. There are many more detailing sounds of heart that are also known as heart murmur. Much detailing is there in this case in medical science, but this is the basic. And you have seen stethoscope in the neck of doctors, so that stethoscope is used to listen these lub dub sound. I think you all know what stethoscope is,
Yes,
right?
ma'am. Yes, yes, ma'am.
Now, we are moving to blood pressure. It is the force or pressure that blood exerts on the walls of blood vessels. Okay, means this is just like that. When when a pipe is flowing, means water is flowing to a pipe, then how much pressure is exerted to the walls of that pipe by water. In same case, same thing in case of circulatory system, that blood is flowing throughout arteries and veins, means all the blood vessels. Now the pressure exerted by blood on the walls of vessels, that is blood pressure. Now, this is again the same two types, systolic and diastolic. Systolic is when the left ventricle contracts and pushes blood into aorta. The pressure produced within the arterial system is called systolic blood pressure. Okay, means when this left ventricle is contracting, then the blood is flowing to aorta and the whole body is getting circulated. So when the ventricle is contracting and pushing blood into aorta, that is the systolic pressure. At that time, what pressure is exerted to arteries, means walls of arteries, that is the systolic blood pressure. And what is diastolic? When the heart is resting following the ejection of blood, the pressure within arteries is much lower, that is called diastolic blood pressure. In adults, it is about 80 mmHg. Okay, means simply when ventricle is contracting, at that time the pressure in arteries is known as systolic pressure, and when ventricle is relaxing, at that time pressure in artery is known as diastolic pressure. Okay, so systolic pressure in adults is normally 120, plus minus 10 we can add, and diastolic pressure in adults is normally 80 mmHg plus minus 10. So what is normal blood pressure in adults? 120 by 80 mmHg plus minus 10. Now, factors determining blood pressure. What are the factors that determine the blood pressure? That is, first one, cardiac output. Cardiac output is equal to stroke volume plus heart rate. Okay, what is heart rate? Heart rate is the number of beats per minute. Means in a minute, means in 60 seconds, how many times your heart is beating. That is heart rate. And what is stroke volume? Stroke volume is volume of blood pushed by each ventricle with each heartbeat. Means at one time, how much of blood is being pushed out by our ventricle. Okay, so cardiac output is equal to, in a minute, how much of blood is being pushed out from heart. Is it understood?
Yes, ma'am.
Okay. Now, peripheral and arterial resistance. These are of two types: vasoconstriction, vasodilation. Vasoconstriction means contraction of vessels, blood vessels, Vasodilation means dilating blood vessels. So it is very obvious when vasoconstriction is occurring means the pathway of blood is becoming narrow or rigid, but the volume of blood is same. So when pathway is narrow but the volume of blood is same, then obviously blood pressure to the walls of artery will rise. So vasoconstriction leads to rising blood pressure. And just opposite in case of vasodilation, when uh, vessels are relaxing, so they are having a broader pathway or larger pathway, so easily blood can flow through that pathway. So no pressure is being means less pressure is being exerted to the walls of artery. So it leads to lowering the blood pressure. Yes, that is why in case of hypertensive patients, vasodilating drugs are provided so that their vessels can relax and blood can go smoothly through that pathway. Now, autoregulation, third determining factor of a blood pressure, autoregulation. Adjusting BP in local vessels by body organs independently of systemic blood pressure. Okay, means till now I think we have been understood that though our full body is governed by nervous system, but each area having its own type of local nervous system, right? Means our full whole country is being governed by prime minister, but prime minister do not know each and every person of this country. So that is why administration is being divided in such a way that each and every people get facilitated by any scheme or any policy of government. So that is why panchayat or municipality system is being adopted in our country. So for like that only in our body we are having some kind of local nervous system in every area. So or adjusting BP in local vessels by body organs independently of systemic blood pressure is known as autoregulation. Okay, so it is not means it is not necessary to be to be the same blood pressure throughout the body all the time. When we are doing Sirsasana, then all the blood is coming towards our head region. So blood pressure at our head region will obviously increase in comparison to our legs. So autoregulation is kind of this only, adjusting BP in local vessels by body organs independently of systemic blood pressure. Right? Now, control of blood pressure. Mean blood pressure is controlled by changing total peripheral resistance and cardiac output. Okay, just for these only I have just told you that in case of hypertension, doctor prescribes vasodilator, vasodilating drugs to patients so that blood pressure can be regulated normally. So, mean blood pressure is controlled by changing total peripheral resistance. So, vasodilation is obviously lowering the resistance of vessels. Next is cardiac output is controlled by sympathetic and parasympathetic nerves which affect heart rate and force of contraction. Okay, means if we are we our nervous system is sympathetically active, then it will increase heart rate and force of contraction. But we are in rest and digestive system, means we are in parasympathetic phase, then our heart rate will come to normal or low, and force of contraction will also be low. Next is TPR, controlled by nervous and chemical means to effect constriction, dilation of arteries, arterioles and venules. TPR means total pulse rate, controlled by nervous and chemical means to effect constriction and dilation of arterioles and venules. Okay, same thing, total pulse rate is being controlled by our nervous system only, and that affect the constriction and dilation of arterioles and venules. So when total pulse rate is being regulated by nervous system, then constriction and dilation of arterioles and venules will be regulated, and blood pressure will be regulated according to that. Now, how is pressure measured? In short term, baroreceptors, chemoreceptors, high centers in brain, these are measured. In long term, kidney via renin-angiotensin system. Okay, by these means, blood pressure is being measured. Means if anyone is having chronic hypertension, in that case it is the renin angiotensin system is being checked, and if you will be get amazed by, no, you will not be get amazed, because we have already discussed about the hormones of kidney in excretory system, right? What are the hormones of kidney? Are you guys there?
Yes, ma'am.
Yes, what are the hormones of kidney?
I remember the hormones of the adrenal gland. I don't remember that of the kidney, ma'am.
Okay, you should remember there are three hormones of kidney, and one of them
There's
is,
one renin.
And
yes.
thyropoetics also.
Renin and the
Al-
other one,
aldosterone for the blood pressure.
No, renin is for the
aldosterone.
blood pressure.
Erythropoetics.
Yes, yes, you are right. Erythropoiesis. Sorry, erythropoiesis is the process. Erythropoietin is the hormone. So, renin is released from kidney. Now, renin is one of the major factor for regulating blood pressure. This is one of the major factor. So this hormone is regulating blood pressure in our body. So basically, kidney is a very responsible organ for blood pressure in our body. Okay, so renin-angiotensin system via kidney is being checked for chronic hypertension or long-term hypertension. Now, cardiovascular centers in brain. Yes, I have already told you about vagus nerve. Vagus nerve is 10th cranial nerve. Now, what are cranial nerves?
Nerves emanating from the cranium.
Yes?
The nerves which come out of the cranium, ma'am, the cranial nerves.
Yes. So, 10th means there are 12 pair of cranial nerves. So, vagus nerve is 10th pair of cranial nerve, and it is very very important nerve and this is the only nerve which is coming out from cranium and going to our peripheral body. Means it is crossing our neck. This is the only cranial nerve which is crossing our neck and coming to our lower body. And this vagus nerve controls all our visceral systems. So through vagus nerve, our cardiovascular systems are also being governed. So when through vagus nerve only, brain is regulating our cardiovascular system, and when we are parasympathetically active, then heart rate is being decreased, and when we are sympathetically active, then heart rate is increased and force of contraction is also increased. Okay, you can see here the neural function, means neural pathway from the central nervous system. Nerves are getting connected to heart. There is sensory nerve, there is motor nerve, and there are interneuron. I think you people remember the concepts of sensory, motor, and interneuron.
Yes, ma'am.
Okay. Now, location of baroreceptors in circulatory system. It is present in right common carotid artery, left common carotid artery, left subclavian artery, right subclavian artery, and brachiocephalic artery. So these are the main arteries being branched from aorta. Also in right coronary artery and left coronary artery. So baroreceptors are present where these main arteries are being branched from aorta. You can see here how they are present. Now, this is the governing or administrating system from central nervous system to heart. Cardioregulatory center and chemoreceptors in medulla oblongata. Okay, cardioregulatory center and chemoreceptors are present in medulla oblongata. The sensory nerve fibers are coming from aorta to this medulla, and this parasympathetic nerve fiber is coming from this medulla oblongata to heart or right atrium or SA node. Okay, so SA node is being governed by parasympathetic and sympathetic nerves coming from medulla oblongata. You can see here both parasympathetic and sympathetic nerves are coming from medulla oblongata to SA node. What is SA node?
Pacemaker. It's a pacemaker.
Which generates impulses, which is the
It's
pacemaker.
natural pacemaker of heart. Okay. Now, this is adrenal medulla. Adrenal gland is situated at which place?
Kidney, ma'am.
Yes.
Above the kidney.
Yes, at the top of kidney. So, sympathetic nerve fibers coming to, sympathetic nerve fibers communicating between central nervous system to medulla. Then medulla is releasing epinephrine and norepinephrine, and these hormones regulate the circulation of circulation of blood. So this is the neural control of heart or blood pressure. Here is another almost same, but it's a bit hazy. Chemoreceptors in the medulla oblongata, vasomotor center also in medulla oblongata. Means mainly medulla oblongata is regulating our circulatory system.
Please explain
Glossopharynx,
chemoreceptors.
yes.
Chemoreceptors. What is chemoreceptors?
Chemoreceptors are the type of receptors. They receive chemical information. Okay, means our body is being governed by electrically and chemically. Electrically by our nervous system and chemically by our endocrine system. Okay, so electrical impulses are getting generated by nervous system, and chemical hormones are being generated by endocrine glands. So neural impulses are being conducted or being communicated through neurons, and hormones are being communicated or conducted or traveling through blood. So chemoreceptors are the receptors which are receiving information chemically. Okay. So
So these chemoreceptors, which are located in the medulla oblongata, through the sensory nerves or the afferent nerves, they receive information from the whatever organ or whatever, and they send the impulse to the brain. Is it?
yes.
Okay, got it now.
So this is the picture of chemoreceptors present in this system. You will have a clear picture when I will share the slides.
Yes, ma'am.
Now this is brain, cerebrum, hypothalamus, pituitary, cerebellum, brain stem. You all know this. We have already discussed about brain in nervous system. Now, long-term control of blood pressure involves control of blood volume, sodium balance by kidneys. Okay, means kidney is controlling blood pressure by control of blood volume or sodium balance, because sodium is a salt and kidney is filtering these minerals and all the waste materials from blood. So if kidney is filtering sodium, means if sodium is reabsorbed from kidney again, then blood volume will increase. Or if sodium is being excreted, then blood volume is decreased. So increasing blood volume increasing blood volume is directly proportional to increasing blood pressure. So increase in sodium directly related to increased blood volume, directly related to increase in blood pressure. Now, hormonal control. Renin, angiotensin, aldosterone system, antidiuretic hormone, atrial natriuretic peptide. Okay, these are the hormonal controls by which blood pressure can be controlled in long term. If antidiuretic means renin, angiotensin, aldosterone system is a bit pathological condition from where angiotensin 1, angiotensin 2 releases and hypertension occurs. Then in case of antidiuretic hormone, from where this antidiuretic hormone is released? Yes, you people are being so disappointing.
Ma'am,
No, it's ADH.
It is vasopressin, also written in beside.
Antidiuretic hormone, ADH hormone.
Yes, from where it is released. So much
So,
discussions has been done in this topic, from where it has been produced, from where it has been stored.
Pituitary gland.
Yes,
it is hypothalamus now.
yes, very good. It has been, means it is being produced in hypothalamus, and then it is being stored in pituitary or posterior pituitary. So posterior pituitary is storing vasopressin and another one hormone. What is that?
Oxytocin.
Yes, very good. Oxytocin and vasopressin. These are the very simple terminologies. Two hormones are being stored in posterior pituitary. So antidiuretic hormone. Understand the terminology. Antidiuretic. Uretic means it's coming from urine. Means anti-diuretic hormone means it will control our urinary system. Means if anti-diuretic hormone is releasing in larger amount, or if anti-diuretic hormone is increasing, then frequency of urine will be less. Okay, so it is inversely proportional to frequency of urine. So that is why antidiuretic hormone, if it is increasing and frequency of urine is decreasing, then blood pressure will increase in body. If excretory materials are not releasing, or the extra water is not being released, extra sodium is not being released from body, then blood pressure inside our body will increase. So an increase in antidiuretic hormone is also a cause of increase in blood pressure. Okay, and I don't know detail about this atrial natriuretic peptide. No need to know these details. I'm just telling you for conception. Now, this is a broader picture of kidney and nephron. You have already learned these things in excretory system. Now, juxtaglomerular cells producing renin, showing this picture, and it is being also leveled. So then also please tell me what is juxtaglomerular cells, where they are present.
Glomerulus is the filtering part of the kidney, and juxtaglomerular cells probably might be around that glomerulus only.
Yes, glomerulus is made up of juxtaglomerular cells, and what is being surrounded is glomerulus is surrounded by what?
Bowman's capsule.
Very good, Warman's capsule. So juxtaglomerular cells are producing renin, which is directly responsible for hypertension or regulating blood pressure. Now, this is the pathophysiology of blood pressure. Angiostensin, that is being released from liver, and this angiostensin is being triggered or stimulated due to renin. So, at first, if renin is releasing from kidney, and it is stimulating angiostensin from liver. Then it is producing angiostensin 1. Then angiostensin 1 is producing angiostensin 2. And from lungs, this enzyme is getting released to catalyze that. Then when angiostensin 2 is released, then systemic vasoconstriction occurs. Okay, vasoconstriction is occurring due to angiostensin 2. If vasoconstriction is occurring, simply it will lead to high blood pressure, or it may also go through the pathway of aldosterone, and that will retain the sodium and water in blood. Also it may go through antidiuretic hormone from pituitary, that will also retain water and minerals in body, that will also lead to high blood pressure. So these are the concepts, these are the physiological changes, pathological changes in case of hypertension. Now, this much of detailing you do not need to know. Antidiuretic hormone, suppression. I've told you the basic things. So this is all about the circulatory system and basic. So I'll provide you slides. Any confusion? Any doubt?
No, ma'am.
Okay. So I think we should conclude the class with prayer. Sit comfortably, upright your spine, close your eyes, adopt Namaskar Mudra in front of your chest. Deeply inhale and exhale completely. Inhale deep and long and start the prayer. Sarve bhavantu shukhinah, sarve shantu niramaya, sarve bhadrani pashyantu, ma kaschid dukha bhag bhavet. Om Shanti Shanti Shanti. Now rub your palms. Put those palms on your facial muscles. Feel the warmth. Feel the energy. And open your eyes with a smile. Thank you.
Thank you, ma'am.
Thank you, ma'am.